In this lesson, we are going to learn how to read measurements of common equipments in a science class. We have hundreds, tenths, ones. After the decimal, the number gets smaller than 1. Here we have tenth, that's mean 1 over 10. Here we are hundredths, 1 over 100. Last one, thousandth, that's mean 1 over 1,000. The strategies is always n one place value smaller than the place value of its increment. For example, we are going to look at this picture with 10.00 milliliter graduate cylinder. Before we start, the difference divided by the number of increments. So the difference, 6 minus 5, it will be 1. That's your difference. Divided by the number of increments. Starting from 5 all the way to 6, how many increments will it take? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will take 10 increments from 5 to 6. 1 divided by 10, you will have 0.1. Let's go back to the strategy. The strategy is always in one place value smaller than the place value of its increment. So now let's look up here. What is smaller than tenths? Hundredths. For this device, it will always end at the hundredths. There will always be 2 decimal places. Now we are going to learn how to read the measurements. This is what you're going to see when you have a liquid in your graduate cylinder. This is the water line. Now when we do our reading, we look at the lowest curve or the lowest point, which is called the meniscus. So this lower point right here, which is called the meniscus, which is the lowest point. For sure we know it's going to be 5, 0.1, 0.2, but we know that meniscus did not pass 0.3, 0.2, and 0.3. 5.25. So for sure we know it's going to be 5.2, but the last number, number 5, we didn't know for sure, so we estimated. So it could be 5.26, 5.27. All these numbers are estimated. So your last digit will always be estimated. So let's move on to our next reading. This one is 100.0 milliliter graduate cylinder. So we use the same formula. The differences divide by the number of increments. 60 minus 50 will give you 10 divided by your number of increments. So you have to count your increments from your 50 to your 60. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to take 10 increments. So 10 divided by 10 will give you 1. Now let's go back to our strategies. Our strategies say that always n one place value smaller than the place value of its increment. This number will be the one place. We need to estimate our number for the tenths. Remember, when we are doing the reading, we had to look at the water line, and this is our water line, but the lowest point is called the meniscus right here. For sure we know it's going to be 52 point, it's going to be 0.5. This is my estimate. It can be 52.6, 52.7, all these are correct because the last digit is estimated. So now we're looking at a 175 milliliter beaker. Same thing, you use the same formula, the difference divided by the number of increments. I will take 100 minus 50. That's my difference. Now I'm going to count the number of increments. 1, 2. 100 minus 50 will give me 50. 50 divided by 2 will give me 25. Now let's go back to our strategies. Always end one place values smaller than the place value of its increment. Our increment is 25, so it's the 10th place. And what is smaller than the 10th? The ones. So this is where we're going to estimate. So before we do the reading, we have to go back and label the missing measurement. So 50 plus 25 will give us 75. 100 plus 25 will give us 125. Let's try to figure out what is our measurement on the meniscus. It's going to be 105 to 115 milliliter. Notice the answer are very broad because the value of the increments is very large. Okay. Last one, 150 milliliter Erlenmeyer flask. Same thing, you had to find the differences. So 150 minus 125 divided by the number of increment, which is 1. So 155 minus 25 will give you 25 over 1, which is 25. The same thing, your 2 is going to be your tenths. So your 2 will be your tenths, your 5 will be your ones. We estimate on the ones. And our meniscus is right here. So that will be between 130 to 140. Notice the answer is very broad because the value of the increment is very large.
Now let's go to streamline.com and do some more practice problems that provide us instant feedback so we can self-reflect on our own understanding. And at any time, if you have any question, let us know so we can work with you and help you one-on-one. So in this case, let's look at this problem right here. We have this graduate cylinder and we tell you that the chemical that we are measuring is water. So now we have the chemical is water. So let's do this. In this case, we can look at this very carefully, okay? So what we have here is water in this container. And of course, to exemplify the drawing, we drew this out, and that's the meniscus level. And by now, you should already know how to find the value of the lowest increment, or the smallest increment. In this case, from 50 to 60, so each one of them must be 1. So the best way to do is, if you can do this visually in your head, right now we must know that this must be 55. If that's 55, this is 56, and this is 57. And just like the rule that we went over in the video, we always end on the next smaller values of our lowest increment. So the lowest increment is at the 1s, okay? So right now, this is the 1 right there. So what's after the 1? We have the 10th. So in this case, this right here is 55, so that's 56. So we have 56, okay? So we keep going up, and we get 57. So if you look at this carefully at the meniscus level, that right there tells us it has to be 56 point something, but it cannot be higher than 57. So in this case, the best bet is 56.5, or you can have 56.4, 56.6 if you want to. All of those are correct answer. But you cannot say 56.0. No, because we have to end where we estimated, which is right here. Okay? You can only estimate one more digit to what's given to you. So in this case, let's type in our answer. So what do we have? We have 56.5, and what's the unit? The unit for graduate cylinder is always milliliter, okay? And this chemical formula is what? H2O. So let's type this in. 56.5, or you can put 56.6, doesn't really matter, and the unit is ml, milliliter. And then what's the chemical formula? It's case sensitive H2O, and there you go. That's all we have to do. Now let's go do some more practice problem. I'm going to choose this one, number 4. We have a lot of practice problem for you. Now let's try this one. We have 5 through 6 right here, right away you should already know what is the values of each increment it's going to be. So let me annotate this. So here we have 5, that's 6. So the lowest values increment must be what? 0.1, okay? Because 10 and 0.1 make up 1. In this case, let's go back up here. This must be 5.5, okay? So this must be 5.6. So 5.7, and that is 5.8. And again, the meniscus level is the lowest point. And if you think this is difficult to determine, wait till you see the watermark or the mark of the solution in real life. It's very difficult. Always choose the lowest one, in this case, the lowest point right there. So if that's the case, you notice right there, right? It's right on the line. So we're going to have what? 5.8. But wait a minute. This is not estimated. So we need to move on to the next one, which is need to be estimated. So the next one is what? 5.80. It could be 5.81, but it cannot be 5.85. Okay, if that's the case, you need to check your vision again. Just kidding. All right. So in this case, 5.80 or 5.81, and the unit in this case is milliliter again, and the chemical is water. So let's type it in. We have 5.80 again, and then milliliter, and what's the chemical formula? H2O. Now let's try another practice problem that doesn't work with a gravity cylinder. In this case, we have a beaker. Notice how we have the number set going down, and it's increased as it go down, okay? And then we have one going up. Which one are you going to use? If you pour water or chemical in here, guess what happens to the water? It's going to rise up. So of course you're going to use this side, okay? This side here is basically help you determine how much you use from where you start. That's when you use it. Now let's go back and look at this. So this is our meniscus line level right here, okay? And we see right there, that's 200. Before we go straight to our answer, let's look at what is the values of our lowest increment. From here, 50 to 200, that's 50. So this increment right here must be 25. So now, what's the values place for 25? That's the 10th place, right? So in this case, we have what? We have 200. That's the 100th place. Okay, 100th place, okay? Now, what do we have? Well, in this case, it is exactly 200. Okay? But this is the 10th place, so we had to estimate on the ones. Well, right now, of course, we can have 201, 202, 205, and so on, okay? But the best guess might be like 201 or 202, but I guess it's 200 to be exact in this case, because it's right on the line. And our chemical in this case is hydrogen peroxide, H2O2. Now let's go back and plug in our answer. So our answer is 200 or 201 if you want to, and the unit again is ml. And the unit again is milliliter, ml, and the chemical formula is H2O2. Remember, it's case sensitive, okay? And there you go. Now let's try a real life problem. In this case, we have a flask right here, Erlenmeyer flask. And what we have here is what? From 75 to 100. And where's the meniscus level? You look at this carefully. We're not going to read that part right here. This part, no. We don't read that part. What we're going to read is we're going to read the lower part. Okay, so look at carefully. Always look at the lowest end right there. But in this case, the values place is so big in terms of the increment from 75 to 100. That's 25 right there. So we are going to have a large range of answer in this case. So if we look at this, I would assume that this, of course, not 75, but it should be like, what's this? This is about 1/4 of this, okay? So what we're going to guess is probably 85-ish or 86, 87, and so on, okay? Or even 90 to something. Maybe 90 is a little way up. I would go down with the lower end of 84, 83, okay? So your choice in terms of guessing, but you know right away the concept of guessing at the ones place, because this is the 10th place, right? So notice how we play this guessing game. There are multiple correct answers. All those educated guesses are correct answer. So let's plug in our answer, and we are going to choose this to be 84. Let's do that. So in this case, I'm going to put this 84, okay? And notice how it's not 84.0, it's 84 because we estimate on the ones place. And the unit is ml. And the chemical formula is H2O. Now let's do some practice problem with the real life example of a gravity cylinder. Notice how we have this. This is very difficult to see, right? Look right here. We have the upper end right there, and then the lower end. Of course, we are going to read the low end. That is the meniscus level. And you can see right away from 10 to 20, each increment must be 1. So right there must be what? And you can see there that that's the line right there. So it is 10.1. Notice how I estimate on that one. So we have 10.0. That's the case as well because it's so close to the line. I want to go with 10.0.